All right, 1.6 to 1.10, there we go. All right, 1.6 to 1.10, guys, it actually was one where you had to use the 45-degree angle. Sorry, I couldn't get that it was. I didn't notice that one. So for the others are all the same, but for cos 225, you would write that as 180 plus 45, which is in the quadrant. And cos negative in the third quadrant, you write that as negative cos 45, and then that is negative 1 over. Oh, guys, I'm worried about this. The fact that so many of you are just negative during homework. Okay, very concerned. You given the reason if not. Okay, we're going to do some more of these now. So we can just write. Then we're going to have to start taking homework every week, which I don't want to do because you guys are 17 years old. But looks like I'm going to have to. Okay, we're going to do some negative angles just very quickly. It's not really something new, we just have looked at negative angles here. Okay, so it's the same as the example that we did yesterday. We are going to just write each ratio as a ratio of acute angles again, like we did yesterday. All right, now guys, for this one, because negative 200, we're going to do the same kind of thing as what we did yesterday. Negative 200, how can I write that using, now not 180, but negative 180? If I do negative 180, then what effectual hours you have to get to negative 20, right? So we're going to rewrite this as sine. We can't use positive 180 now because it's negative numbers, right? So we do negative 180, but then we must still subtract 20 degrees from that to get to negative 200. So what is the acute angle that I have in these brackets? 20. So it's going to end up being either positive or negative. We're going to figure that out now. Sine of 20. Okay. We need to figure out which quadrant this is in. So again, it's useful if you have a little Cartesian plane, just draw it on the side with your class diagram letters put in. And now remember when we're doing negative angles, we start at 0 and we go backwards, right? So we're going to go 0, that's negative 90, negative 180, and then we must still subtract 20 degrees, right? That's going to end up in quadrant 2. And what is sign in the second quadrant? Sign in quadrant 2 is positive. So this is going to become positive sign. Let me do another one. Cos of negative 120. Now, because it's negative, we can't use 180 minus 180 plus. Sorry, we're going to have to do negative 180 minus or negative 180 plus. What do you guys think? To get to negative 120, we do negative 180 plus 60. All right, so we're going to do cos negative 180 plus 60 degrees. Okay, which quadrant is that going to be in, guys? We do negative 180, that takes us to that line, and then we add 60. Right? Quadrant 3. What is cos in the third quadrant? Negative. So this is now going to become negative cos, and what would the acute angle in these brackets? 60 degrees. So negative cos, guys, 60 degrees is a special angle, right? So let's draw our special triangle again. I know we drew both of them yesterday, but let's just keep doing it so that we remember them easily. Right, can we remember from yesterday, the shortest side is opposite the smallest angle, right? Which angle is the smallest? 30. So the shortest side is 1, so that must be opposite the 30 angle. Then we go around, we do 2, that's the hypotenuse, and then root 3 is that third side. And like I said yesterday, you do get a mask for doing this, so if it's not there, you're going to be. Okay, cos 60. Remember, guys, negative. So let's put that minus there straight away because we don't forget it. Now we're going to say cos 60. So we're looking at the 60-degree angle, and cos is adjacent over hypotenuse. Right? So 1 over 2. So negative or half. I just want you guys to just do like 4 of these quickly on your own because then I'm going to move on to something. And I do want you just to practice these. I'll put it on the board, but it's exercise 11 on page 151. Let's say the first 6. So 121, no, actually, wait, let me change these. Let's do Okay, so I'm going to give you specific ones, but it's basically the odd numbers ones, the first five of those. Okay, you're going to do that now quickly. I'll give you 10 minutes. Yeah. Okay, all done writing that down? All right, guys, there we go. So it's those first five, right? Just on the side, 1, 3, 5, 7, and 9. Okay, I'm going to give you until about 25 past. Okay, so it's saying they simplify the following without using a calculator. So for this first one, it is a fraction. I'm just going to write it over 2 lines. All right, now for these ones, it's just like how you did now, but there are 6 of them in one. Right, so for cos 240, we're going to have to write that as an angle with an acute angle so that we can reduce it. So what do you guys think? 240. 180 plus 16. Yeah, is that fine? Okay, let's do that. Cos 180 plus 16. And which quadrant is that in, guys? 3. Which is going to help us with the next step, right? In the next step, we're going to have to take the sign of that quadrant. Okay, now we're basically going to do that for all 6 of these. So sine 315, what do we think? 180 plus, that's a bit much, hey? That has to be in a cube. 360 minus 45. Yeah, let's do that. 360 minus 45. And that's in quadrant 4, right? Let's do 4. Okay, then we have tan of 120. We're going to write that as tan of, what do you guys think? 180 minus 60, good. And that is in quadrant 2. At the bottom, we have sine 150. I'm going to rewrite that as sine 180 minus 30 degrees. You guys notice that we're actually using special angles for all of these, right? My first bracket is 60, there's a 45, there's a 50, that's a 50 now. So all of these are special angles so far. Back in problem 2. For tan 210, that's going to be tan of 180 plus 50 degrees, which is quadrant 3. And then last one, cos of 225, 180 plus 45. And that is quadrant 3. Yeah. Yes. All right, so next step. Now we're going to take all of those signs in those quadrants, right? Cos in the third quadrant. Negative. So this becomes negative cos 60 times sine in the fourth quadrant is also negative, right? So this is going to become negative sine 45. And tan in the second quadrant is also negative. So negative tan 60. Sine in the second quadrant, that one is positive. Okay, so that one is nice. Sine of 50 degrees times tan in quadrant 3. What's that? Positive or negative? Positive, right? Cos, you're using quadrant 3. Alright, so that's tan of 50. And then the last one, cos in the third quadrant is negative. So negative cos 50. And at this point, if you had any of the same ratios at the top and the bottom, you could cancel them off. To say we had a cos 60 at the top and a cos 60 at the bottom, you would be allowed to cancel those off, right? Before having to actually find what those values are. Let's look at all the minuses. Can I cancel any of these out? Negative times a negative is a positive. So draw a line through them, but guys, please make sure that the marker can see that you had negatives there. Yeah, because you get marks for knowing that this is negative cos 60, negative sine 45, and so on. And then we have two more negatives. A negative divided by a negative again is a positive. So those two negatives also cancel off. There's nothing else that's the same. Alright, so now what we're going to have to do is we're going to have to draw our two special triangles because guys, we have 60 and 30 degree angles, but we also have 45. Okay, so we do need both of them. And then we're going to have to find those values, sub them in, and calculate what the actual answer is. And very important, guys, maybe just highlight where it says without using a calculator. You can't now go and type all of this into the calculator and get an answer. Okay, you're going to lose marks because then it's going to be obvious to us if you've gone straight from this line to the answer that you. Okay, so quickly again, it's the last time that we're going to draw these triangles today, I promise. We have our 30-60 triangle. And we also have our 45, 45. And once you've done drawing in, you can find what to find all of those values. So, cos 60 is the first one that we have to find. We actually did that for the previous example, but just again quickly, 60 degrees cos is adjacent over hypotenuse. So that first one we're going to replace with a half. Okay, so we're going to do 1/2. That is cos. Next up, sine 45. Remember we cancelled out all of those negatives. So sine of 45, you're looking at the 45-degree angle, and it's going to be opposite over hypotenuse. So 1/√2. And guys, it is important that you write it like this. I'm going to show you now what happens if you try and be sneaky and you try to use your calculator here, even though I said you're not allowed to. If you type sine 45 into the calculator, it gives you this, √2/2. And guys, how is 1/√2 the same as √2/2? You remember in term 1 when we worked with surds, and we spoke about rationalizing the denominator of a fraction. So making or changing a fraction rather so that it doesn't have a surd in the denominator. Do you guys remember how we did that? What did we have to do to get rid of this √2 at the bottom? Not square necessarily, because then you're doing kind of a different thing at the top and the bottom. What multiplied by what will cancel out a square root? The square root multiplied by another square root, okay? So we used to do this. I'll just do it on the side here. So if we had 1/√2, then you would times the top and the bottom by the surd that you have at the bottom. Right, do you remember that? Because now √2 times √2 is, you were correct now, it is √2 squared, which is just 2. But what do you have at the top? √2/2. And that is what the calculator does. Right, the calculator rationalizes the denominator automatically. But the special triangle uses the simplest forms of those signs. Right, so 1 and 1 and √2 instead of 2 and √2 and √2. Okay, so guys, if you are using your calculator here, then you're not actually supposed to, and you write √2/2, you're going to lose 1. Okay, so please be aware of that. Okay, next one, tan of 60. Again, we're looking at 60 degrees. Tan is opposite over adjacent. So √3/1. You can just write √3 if you want. And over the 3 in our numerator. Now, sine 30, we're looking at 30 degrees. Sine is opposite over hypotenuse. Again, 1/2, right? The same as cos 60. Why is that again, guys? Why do I get the same answer for cos 60 and sine 30? What are they of each other? The specific name for those ratios. It's the complementary angles. Yes, 30 and 60 degrees. Okay, so that's why those two are actually equal. Let's do tan 30. Tan is opposite over adjacent, right? So now it's going to be 1/√3. And then the last one, cos 45. If you look at either one of these two 45-degree angles, it doesn't matter, you'll get the same answer. Remember, cos is adjacent over hypotenuse. So also 1/√2. Now guys, again, we see that sine 45 and cos 45 will equal. Again, those two are co-ratios, right? Because 45 plus 45 is 90. Okay, so they are actually equal. Is there anything now that I can just cancel out? The halves and the 1 over root 2, okay? So I'm left with root 3 divided by 1 over root 3. Guys, what do you do when you divide by a fraction? You change it to second time, okay? Yes, good. You change it to multiplication. So I'm just quickly going to write in a separate step, just so that you know what's happening if you look back at this. We actually have root 3 divided by 1 over root 3, which we now have to change to root 3 times. So that's the times, and then we must also tip the fraction. So root 3 over 1, which is basically just root 3. Right? And what is root 3 times root 3? 3. Okay. Those square roots cancel each other. So all of this that we started with is equal to 3. And like I said, also you can't go straight from this line to your answer. I mean, you can do this division in your head, I suppose, but then you at least have to show what you're canceling off. Okay, don't just have this fraction and go to 3. Okay, they're probably going to assume that you just use your calculator. Yeah. Yes, as a compound fraction. Yeah, you can, but then just write it there on the side. So then do times root 3 and times root 3. Perfectly settled for you. Okay, any other questions? All right, we're quickly going to do one where we have to rely on co-ratios very heavily. So number 2. Just going to do it like in this gap. See if I can fit it in, otherwise I might have to move it in. Do this one. Cos of 17 minus sine of 150 plus cos, sorry, again, this is a fraction, guys, sorry, I should have said, plus cos of 214 times cos of 250. And that is all over 520. Now guys, what I want you to notice here is that we actually already have 2 of these that are written with acute angles, right? 17 is an acute angle. So we're not going to do a 180 minus or 180 plus or anything like that. We're going to leave it as it is for now. And sine 20, that's also already written with an acute angle. The others are not. Okay, so the others we're going to have to change. So like sine 150, what am I going to rewrite that as? What do you guys think? Yeah, so cos, sorry, it's cos 70, there we go, and then sine of 180 minus 50. And that's quadrant 2. So I'll just write that there so long. That's going to help us decide on the slide. The next one, 240. 180 plus 60, yes. 60 and 250. 180 plus 70. Now guys, that's a bit odd because that's not a special angle, right? Okay. For the next one, yes. I've done this one for yeah. The next one is going to be 180 plus 70. Okay, that is a bit strange because like I said now, that's not actually a special angle, but there was another 70-degree thing here, hey? So maybe we are on the right track. Okay, so cos 250, we're gonna rewrite that as 180. Sorry, I'm gonna have to move this a bit. 180 plus 70. And that is then all over sine 20, which we're gonna keep as it is for now. I forgot to put the quadrants of these other ones. 180 plus is quadrant 3, and 180 plus again is quadrant 3. Okay, so now let's just change all of those quickly according to their signs in those quadrants. Cos 70 again, I'm leaving as it is. Sine in the second quadrant is positive, right? So that's going to just become positive sine 30 plus what's cos in the third quadrant. So this is negative cos 16. And then the next one is also in the third quadrant. So that is again, oh, sorry, negative cos 70. So what's going to happen with those two minuses? We're going to cancel out, right? But guys, at first, please, you must write them as negative so that the marker can see that you know that cos is negative in the third quadrant. Okay, then you can do your line through both of those minuses. And that is over sine 20. Okay, what now? Can I change cos 70 using a special triangle? And I get the actual value of that. Am I allowed to type that into the calculator to see what it's equal to? No, it's said without the calculator. Okay, so for now, we actually can't do anything with these two cos 70 and also not with the sine 20, right? Because that's also not a special angle. But what about sine 30 and cos 60? Can I work out what those two are? Okay, let's look back at our triangles. We're not going to draw them again. The test for exam also, guys, if you're using these triangles in more than one question, you only have to draw them once in your whole lesson. Okay, so when you draw them once, you're only going to get a mark for them once. So the first time you use them, you draw them, and then you can just use those same triangles for it. Okay. So what is the first one? The sine 30, which is a half. And then cos 60 is also a half, right? Cos 60, we're looking at 60 degrees adjacent over hypotenuse. So these are both a half. Okay, so I'm going to rewrite this now as half cos 70. If you agree with that. This is one term, right? Cos 70 times sine 30. So cos 70 times a half. So the sign would be bad, but I just put the half in front. Half cos 70. Okay, that's usually what we do. You put the number in front and then the variable at the back. Then here I have another half cos 70. I'll just do a little, I'll just highlight the sine 30 and the half, and the cos 60 and that half. Okay, that's where those halves are coming from. And that was over sine 20. Okay, what's a half cos 70 plus a half cos 70? 1, right? Well, if we add in, so what's a half plus a half? 1. Okay, so a half cos 70 plus a half cos 70 is going to be 1 cos 70. Okay, you can just write cos 70 for that. So we have cos 70 at the top, but guys, what about the sine 20? We've been carrying this the whole way. And if I have cos 70 over sine 20, I can't actually do anything with that. They're not the same. So what do you think I can do then? Good, big corner ratios, hey? Cos 70 and sine 20. What's 70 plus 20? 90. So let's just make a note of that quickly. I'm going to zoom in a bit. So here, These two are co-ratios because 70 plus 20 is equal to 90. And guys, I actually think we use this as an example. We work with one was 70 and the other one was 20. I can't remember now, but I think so. So guys, what you're gonna have to do is you can now decide. Cos 70 you can keep at the top, and sin 20 you're gonna rewrite as cos 70. Okay, so we can do this. Cos 70 over cos 70. If you type into the calculator, I know you're not allowed to at this point, but just to remind you, if you type in sin 20, you get 0.34, and cos 70 is the exact same thing. Okay, so they are actually equal. So you can change sin 20 to cos 70. Or if you want to, you can change cos 70 to sin 20 and leave that sin 20 at the bottom. Either way, it's fine. And you can decide, you want to change the top or you want to change the bottom. You have to show that you're changing one of them. Okay, you get a mark for that. And now guys, what is anything divided by itself? 1. Okay, so that's something to be on the lookout for, guys. Often when you're working with, when they're giving you acute angles that are not special angles. So here we have 70 and 20. They're not special angles, so we can't use the special triangle. Then you're going to have to work with co-ratios. Okay, change them so that they are the same, and then you can cancel them. And let's also just highlight co-ratios here. It's very important. Okay, something to look out for. So for example, also sin 10 and cos 80. Those are also equal to each other. Sin 40 and cos 50. Okay, those are also equal to each other. If the two angles add up to 90, then they are equal. They are, but it's not an equation. All right. I'm going to give 2 of these to practice, so it's not a lot. Let's see. I'm going to give you one that doesn't use co-ratios and then one that does. So it has to be in 2 different exercises, sorry, because they are split up like that. So exercise 13 on page 153, I want you to do number 2. And then exercise 14 on 154, if you can please do number 2.4. Now guys, in 2.4, there is one of the ratios that you need to work with is sine of negative 53. Now you don't actually have to write that with any brackets or anything, right? Like a 180 minus or 180 plus, because what quadrant is negative 53? 0, and this one is negative 90, quadrant 4. All right, this one is in the 4th quadrant. It's like when we had negative x or negative theta, it was just in the 4th quadrant. So what is sine in the 4th quadrant? Negative. So this is just going to become, sorry, I'm running out of space, negative sine 53. Okay, that's all you have to do for that. So whenever it's a negative acute angle, it's in the 4th quadrant, so you take the 4th quadrant. All right, there are still 7 minutes left, so I'll put the first one on the board for you guys, and you can start working on that one. Are there any questions before you start practicing? Okay, which one was it? Number 2. It's over there. Once. Hmm.